We're going to now move on to something a little bit different using some great free software called Praat. So the first thing for you to do, if you haven't done this before, is to go and download Praat from the internet. You can just Google Praat download and that'll give you downloading Praat for Windows and downloading Praat for Macintosh. Once you've downloaded it and opened it, you should see something like this. So as I say, we're using Praat. We're going to be looking at waveform displays, which are one way to visually display speech. Some of the discussion is based on a section of Eric Thomas's excellent sociophonetics book. That section and a little bit more is available to you in the Blackboard site. It's an optional reading. Also, I've linked you to an excellent tutorial here on understanding waveforms. You can find that through this web page, which is linked in Blackboard. All of this is optional if you want to get a little bit more, or if you find that there was something in my presentation that you didn't quite get. But I'm hoping that you'll get what you need just from this lecture. So first of all, what is a waveform? Well, it's a display that plots sound pressure up and down, which is related to the amplitude or the intensity of a sound against time on the horizontal left to right axis. So to see a waveform, we're going to look at a sine wave that we're going to create, or a set of sine waves that we're going to create in Praat. So we're going to go to Praat. We're going to select New, Sound, create new sound as a pure tone. And to start, we're going to work with a tone frequency of 200 hertz and an amplitude of 0.2 pascals, which should be the default when you open it up for the first time. I just created the sound. Now I can play it. And it doesn't sound like much. That's just a very pure tone. And we can view it and edit it here. So one thing that we can do right away is select a portion of the sound. Once we've selected a portion of the sound, we can play that portion. This is a shorter bit. This bit over here is longer. Play the whole thing. And then we can zoom in and out. And one very useful thing is to be able to zoom into the selection and just see that bit that you've selected. Then we can go back out. Okay, so again, that's our waveform. This is plotting intensity in terms of pascals. And then across the horizontal axis, we have time. This goes from 0.05, 5, 6, 7. This is the measurement of time at the beginning of the selection, and this is the measurement at the end. And this shows how long this part of it is. We're going to create two more sine waves. So the second one, we're going to leave the tone frequency at 200 hertz and change amplitude to 0.4 pascals. So back in Praat objects, new, sound, create sound as a pure tone. We said that we were going to change now the amplitude. So it's going to be a louder sound. It's twice the amplitude of the previous one. So you should be able to hear the difference in amplitude when I play the two. And then for the third one, we're going to use 400 hertz and 0.2 pascals. So this one's going to be twice as high. It's going to be higher amplitude. So sound, create sound as pure tone. We are going to double the frequency and then put the amplitude back to where it was in the first one. Okay, so this one and this one have the same amplitude, but the frequency is doubled. And the high one might sound a bit higher. That's just because The higher frequency sounds tend to perceptually seem louder. What we're going to do now to look at them is to combine them. So on a Mac, I'm pushing my finger down on Shift and selecting them. And then I'm going to combine them. So this is following the directions here. We're combining and we are concatenating. We get what's called a sound chain, and we'll look at all three of these. So this is sound 1, sound 2 here, and sound 3. And I'm just going to pause for a second and ask you to think about and look at how frequency relates to what you see in the waveform display. Now, you should have done all of these steps yourself and had the same display that I had right there. One thing about my display is that the window originally is smaller, and I've stretched it out, and you might want to do that to be able to see them a bit better. So first of all, how does frequency relate to what you see in the display? So we know that this sound is higher frequency than, this sound is higher frequency than these two. And then how does amplitude relate to what we see in the waveform display? We know that this one is higher amplitude than either of these two. And again, if you want to look at a little bit more closely, you can select something here that's like about a 0.1 of a second and look at it. And then you might go over here, say, and select one that's something like 0.1 second and compare those two. Right. So let you do that. Press pause on your video. So you should have seen that in the display that these waveforms are happening more frequently, closer together. That's the higher frequency than in either of these. And in this case, that the waveforms are larger, they go higher and lower than either of these ones. That's the difference in amplitude. Frequency, I've been talking about hertz and haven't defined it yet. It's the number of cycles in a second. So it's really easy to see these repeating cycles in the sound wave. I'll just go in and look at these ones. So here from 1 0 crossing to another, so we've gone up and down, and you'll see that from here the same pattern repeats and then repeats again. So the frequency is how many of those cycles or periods we get in a cycle. In a second. And we can just measure the frequency of the sine waves by hand, and we'll try to do that. So first of all, I'd like you to go and select a portion about 0.05 seconds. So, we started around 0.12, so it should be around 0.17. It's close to 0.05. So let's zoom in. And then we're going to select, we're just going to put our cursor right at one of these 0 crossing, right? So this is positive, this is negative, there's a 0 crossing. And then I'm going to do a little trick of moving the end of the selection by exactly 0.05 seconds. So time, move end of selection by, and the default is 0.05, which is great, and we'll just do that. And there's the selection, and then I'm going to now hit select to view just the selection, and ta-da, our visible part is in fact 0.05 seconds. Now, in 0.05 seconds, how many cycles are there? Well, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you would get a different answer if you had selected the higher frequency sound. And why don't you go along and go and do that one instead, just to see something a little bit different. If we chose a selection from one of the 200 hertz sine waves, we should be able to count 10 cycles. Now you might just hit pause and think about that for a second. Why should it be that in the 200 hertz sine wave, we should be able to count 10 cycles? Pause. Okay, so the answer to that is because these selections are 1/20th of a second, then 20 times 10 is 200, right? So that gives us the number in a whole second. And similarly, if you kind of go through that logic, and you should be able to think that if you chose a selection from a, I say 100 hertz sine wave, that should be 400 hertz. That's a mistake. Then how many should we count? Not 5, some other number. You can think about that one through yourself. Alternatively, we could just select one of our cycles, measure it, and this should be 0.05 in length. Now, it's kind of hard to measure it exactly, and that's why we didn't use that method. But we could just divide that into 1,000, and we would find that the 1,000 divided by 5 gives us the 200. We'll move on to pitch in speech and measuring pitch in the next section. But what I would like you to do before we do that is to record, initially stress appa, abba, ama, asa, afa, ava, and awa, and look at the differences in the consonants. So remember that when we talked about consonants, we talked about how the pa and the ba are the most consonant-like. So what do you see in the waveform for appa and abba that's different from some of the others? Can you see something that's different between pa and ba? Can you see something that's different between fa and va? And wa as well. And so that'll be the end of this unit. I hope you found it interesting, and I hope you're looking forward to the next one.